A fundamental tool in pretty much every programming language is the ability to loop, to do something repeatedly, to iterate. In the context of R, one of the most common use cases for loops is to be able to iterate or loop through your data. We're going to look at two ways of doing this. One is using explicit iteration. We're going to use a for loop where we're going to very explicitly define the parameters of our loop. Then we're going to look at implicit iteration. We're going to get into vector operations, which is one of the most useful tools in R, where we're going to be able to iterate through things like sets of data, but we're not going to have to write out the specifics of how that's going to happen. R's just going to kind of take care of it for us. So with that goal in mind, let's jump right in and let's start with a very basic example of a for loop and explicit iteration. I'm going to copy this example from the notes, bring up my R script, paste that in, and what we have here is a for construct. This is a built-in R keyword, and following that in parentheses, we're going to have the parameters of our for loop. The first parameter is going to indicate a cursor, essentially, that's going to walk us through this loop. I called this I. It's short for iterator. It's very common in programming languages when setting up for loops. We set our cursor to be called I. And then we're going to say in. This is another built-in R keyword. And then we're going to specify some range of values that we want to iterate through. So here I'm just defining a vector of the numbers 1 through 5. So what's going to happen in this for loop is the first iteration through the for loop, I, is going to be set to 1. In the loop itself, this is the code that it's going to execute, and then it's going to repeat that. So the next time through, the next item in our sequence is going to be 2, so I will be 2, and it'll continue on this process, printing this line each time until eventually I gets to 5. At that point, it'll be done, and it would continue on with whatever code follows the for loop. Zooming in, let's look at what this is actually doing. So what it's doing is just printing a basic statement that says this is loop number, and then it's going to output what I is, just so we can very clearly see what's happening in this loop. Let's go ahead and run this code. And there is our output. So we have 5 lines, and we could see the first iteration through the loop number is 1, and then 2, 3, 4, 5, etc. And of course, via the power of programming, we could very easily scale this up, and let's set our n range to 500. Expanding on this example, let's see how we can apply a for loop to iterate through a set of data. I'm going to go back to the notes that accompany this video. I've set up an example data frame we can work with. So I'm going to copy this and bring it in. We'll add a view so we can look at this data, and we'll execute it. And this is just example data from a hypothetical Stroop experiment, so we can see the responses for 10 different trials for a single participant, things like their response time, etc. Now that we're familiar with the data, let's work up a basic example where we're going to loop through it using a for loop. So we're going to say for I in, we're going to start at 1, and then we could just say 10 because we know we have 10 rows, but let's make this a little bit more dynamic. We'll use R's nRow function and have it fill in how many rows of data we have. Then within the for loop, to access each row, we're going to reference our data frame, and then we're going to index based on whatever I is, right? So the first time through, I is going to be 1. So this will give us access to the first row in our data frame. And the column we're interested in is going to be the response time. So let's just print that out. And perfect. There we can see the response time for each of our trials. Let's make this a little bit more interesting rather than just iterating through the data. Let's do a manipulation on the data as we go through. Specifically, let's add a new column where we're going to categorize the response time as either fast or slow. We'll say if the response time is less than 500, we'll say that was fast, and anything else will be categorized as slow. To do this via a for loop, the first thing we want to do is we want to set up this new column in our data set. So I'm going to say Stroop data, and then we're going to come up, we'll call it response time category, and we'll initialize that as NA. Then within our for loop, to decide whether the response time was fast or slow, we're going to use a if condition. So we're going to say if our Stroop data at the current iteration, we're looking at the response time. If that's less than or equal to 500 milliseconds, we'll access our data at the I position, and we're going to update that response time category column, and we're going to set it to be fast. Otherwise, or else, we'll do the same thing, but we'll set it to be slow. And let's go ahead and run this. And then look at our updated Stroop data. You can see our additional column was added. And if we just do a quick spot check, we can see that the appropriate values were set. Now, this process I just showed of looping through a set of data and performing some manipulation is something you're going to do all the time in R. And so R has built-in functionality to do this for you essentially behind the scenes. This functionality is referred to as vector operations, and you're going to find it's built into a lot of R's default functions. For example, let's say we wanted to add up all the values for the response time column. We could use R's built-in sum function. We'll reference our data frame, and we're just going to specify the column we want to sum up. So there's our resulting value. And you can almost imagine behind the scenes what R is doing. It's essentially doing the same thing we're doing with the for loop, where it's like, okay, we got to start at the beginning, go through every row of data and collect the value for this particular column. We're going to sum it up and then return the results at the end. The difference is we're not seeing that for loop in our code. We're just passing it the collection of elements, and we're letting R do the work behind the scenes of iterating through those elements. For another example of this, let's accomplish what we did in the for loop where we're creating this new response time category column, but let's do it via vector operations. The code for that's going to look like this. So this line of code is taking advantage of R's built-in if-else function, which is different than the if-else construct. This is just a regular function in R. It takes 3 arguments. The first argument is a test or a Boolean expression that will evaluate to true or false. If it evaluates to true, the second argument we pass our if-else function is going to be what is returned. If it evaluates to false, then the third argument is going to be the value returned. So in our case, we want to look at the response time column or the value for that column. If it's less than or equal to 500, we want to return fast. Otherwise, we're going to return slow. So in short, we basically gave it a summary of what we wanted to do. We specified a whole collection of elements that we're going to be applying this logic to. And because the if-else function is designed with vector operations in mind, it knows that it has to iterate through each row of our Stroop data, applying this logic to it. And the end results are all going to be fed into the response time category column. Just to show that this works the same as the for loop, let's rebuild our original data set. So if we take a look at it, we no longer have the response time category, and we're going to skim down. We're not going to do the for loop this time. We're going to do this single line of code. And then if we look at our updated data, you can see the response time category was added with the appropriate values for each. So 2 different approaches, the same outcome, but hopefully you can appreciate how vector operations provides just a much cleaner and terser way of accomplishing the same thing we can with for loops. The other nice thing about vector operations is they're often much more efficient in terms of how long it takes to process this code. The reason for that gets a little technical, but basically behind the scenes with vector operations, R is creating this optimized low-level code that processes entire data blocks at once instead of handling elements one by one, which is what happens when we use an actual for loop. Now, this optimization and speed difference, you're not going to notice on small examples like this. This code is going to be indiscernible from this code in terms of how long it takes to process. But this is something as your data sets grow larger, maybe you're dealing with 100 gigabytes, 1,000 gigabytes of data, these sort of little optimizations can add up. So in summary, there are 2 benefits of vector operations versus for loops. The first is cleaner code, and the second is potentially faster code. And hearing those 2 things, you might wonder, well, why would you ever use a for loop in R? And the answer to that question is there are certain use cases where a for loop is going to make more sense. Let's go back to the notes for this. I'm looking at the section when loops are still useful. Here it highlights that vector operations stand out when it comes to data manipulation and calculations, but loops are better for more procedural tasks. For example, if you need to perform actions that have side effects, such as working with files, printing messages, that sort of thing. If you're working with incremental building, maybe some later iteration depends on the result of an earlier one. A for loop's going to make more sense there. And then just in general, sometimes the clarity of a for loop is going to be more preferable than vector operations, right? Vector operations sort of tucks a lot behind the scenes what is happening, and sometimes being able to explicitly see how the iteration is programmed via a for loop can have some advantages. At the end of the day, like a lot of programming, we often have multiple tools that can accomplish the same job, and it's about picking the tool that makes the most sense for whatever task you're working on.